Okay, so page 530, number 10. So the first thing is number 10 doesn't give us a picture, but it says we have a rhombus and the diagonals are 18 and 24. So what I did was I just created one diagonal that is 18 and the other diagonal is 24. Now, of course, when those diagonals hit each other, because this is a rhombus, they bisect each other. So the diagonals are perpendicular bisectors. It's the equidistant theorem. And then I also noticed that because that was 9, 9, 12, 12, that this becomes a 3, 4, 5, just 3 times bigger than a 3, 4, 5. So I put the sides were 15. And then I started to just kind of play around from there. Because a rhombus is technically a kite, I can use the formula for area. So I just use that the area is 1/2 times diagonal 1, which is 18, times diagonal 2, which is 24. And so I just thought maybe the area could help me in this case. So this would be 9 times 24. 9 times 20 is 180. 9 times 4 is 36. And when we add those together, we get 216. So I noticed that the area of this rhombus is 216. But I also thought to myself, not only is a rhombus a kite, but a rhombus is also a parallelogram. And that is helpful because the area of a parallelogram is base times height. And the height is what we're looking for. So we're trying to figure out what the height is. But lucky for us, we know that the base is 15, and we also know that the area is 216. So I plugged in 216 for the area, I plugged in 15 for the base, and then we have the height here. So divide by 15, divide by 15. Simplifying this fraction, I think each of these numbers are divisible by 3. 21 divided by 3 is 7, 6 divided by 3 is 2, 15 divided by 3 is 5. So the height is 72/5, or 5 goes into, so when I'm doing this in my head, if I was splitting this up, 72 divided by 5, I would say 50 divided by 5. So in my head, I'm like, okay, I have 10, and then I have 20 divided by 5, which is 4, and then 2 divided by 5. So I know that it would be 14.4. So that's kind of what I'm doing in my head. So either of these answers were completely acceptable.